get started. So now I'm going to discuss about what is observability and how it is different from monitoring. So sometimes what we do not focus on the monitoring and setting up observability. Why? Because we think our host is giving sufficient information. So when I say monitoring, that means I'm not talking about the high level monitoring. I'm talking about the detailed monitoring, the monitoring in depth. So you can get insight and you can forecast the future also. That means the issues might pop up after 1 month, but you are having a data of today and you can forecast that. This kind of situation I'm talking about. So many people say, hey, we have AWS, Azure, Google Cloud, and all. We are running on it. We are giving sufficient stats. So that's a common mistake which we do. The big mistake which we as a project we do, we think, okay, we are already established player without monitoring, and we are number one right now, generating lots of money. And why don't we have to spend our energy on the security and monitoring and stuff like that? We don't need that. So that's one big mistake we as a project, if you do that. And third, we say we don't have a time. We don't have a time because we have lots of priorities, released work, development efforts, QA efforts, this efforts, that efforts. We don't have a time to complicate this this monitoring. Basic monitoring is place, and that is where that system is failed. See, everything is okay. Your CPU infra is under control. You know, all the apps are running. CPU is under control. Memory is under control. But system is failing. So how do you know that? What is the problem? So now you will realize that okay, maybe it's hacked, and hacking is not happening in one day. I I hope you understand this. It's not happening in one day. It takes 2 to 3 years to hack. Correct, no? All of you. Slowly, they will get into the system, understand the environment, create a platform, and one day hacking the will happen. The preparation is of 1 year, 2 years. Correct, no? All of you.
Yes.
So that means 2 years you were thinking my system is perfect, running flawless, and everything is great. But actually, you're being hacked, and you will realize that mistake, and then you will seek for help. Right? I have made a huge mistake. Okay, and your CTO might come to you and say, what you guys have done. You know, you should have done it much earlier and all stuff like that. So he's a cute CEO, right now. So so that is where the monitoring, one of the keyword which is there from in the industry from last 20, 30 years. We all discuss monitoring, collecting the information, matrices. It's nothing new world is there from last 20, 30 years since we are running the software in the productions. So monitoring is a systematic process of collecting and analyzing and using that information. So collecting what information I'm talking about? Here information means any idea what information you are trying to collect and analyze and use? Anyone? Let me ask this question to Praveen. So when I say information, what information you are talking about?
The collecting of data of
Collecting of matrices. So from
metrics.
today onwards, let's start calling matrices.
Okay.
Data is not data can be different. See, everything is data nowadays. Correct, no? But
Okay.
here, when we are in the world of monitoring, information means your metrics. Metrics is your information. What metrics I'm talking about? Anyone else? Let's say, guys, you can volunteer yourself, or else I have to change my window all the time to see your name. Hari, what do you think? Hari? Yeah. So, Pritam or anyone else, what kind of information I'm talking about? What kind of matrices?
Might be server logs.
Logs. Okay, good input. Something else? Someone else?
The usage.
Usage? No. So this,
Alerting.
so when I say information here in the world of monitoring, it can be matrices. Matrices like a CPU is a matrix. RAM is a matrix. Disk space usage is a matrix. System up and running is a matrix. Process up and down is a matrix. Services up and down is a matrix. Someone said logs also. Log is a matrix. A logs is a log, right? Log also contain information for monitoring, right? And I think some of you said like you want to learn APM in detail, correct? APM means what? You send a request to some website. I'm putting in a very simple way. You are sending a request to some website, and then response is being generated. That is called trace. That's information. So here, monitoring is a process for collecting. First, collect that data. CPU collection. I want to collect my system CPU, RAM, hard disk, network, and logs and traces, and analyze using information to track a program's progress towards reaching its objective and to guide management decisions, whether it's in this matrix is a expected matrix or this matrix is is not expected matrix. So that's a monitoring, we all know that. So why do we do the monitoring? And I think more or less we understand that we do the monitoring because we want to check the system health of the system, health of the server. We want to know the health of applications also. We want to know the user experience also, whether our users, end users, let's say you are accessing the Amazon.com, you must be doing shopping. I think Flipkart sales is going on, right? So some of you might have done the shopping as well. How was the experience? Browsing the website, navigating through the different UIs, login, registration, selecting the product, putting in the carts, and then making a payment, and then checking the orders, and then tracing the orders and all stuff like that. How was your experience? That's the experience I'm talking about. So why do we monitor? Simple things. We want to check the health of the server. We want to check the health of system. We want to check the health of the applications. We want to see the user experience. We want to check the user experience. And for that, we monitor. Make sense, guys? All of you?
Yes, Rajesh.
Yeah. So analyzing the long-term trends, comparing over time or experiment groups, alerting, building dashboards, conducting ad hoc retrospective analysis, debugging and all stuff like that. These are the things we do as part of the monitoring. So we need monitoring. Okay, so these are the some stats. What are the primary uses of monitoring and observability data? So you see that most of the data which we use it for alerting, that data means information means same thing, matrices, logs, traces, the data, that's the data. Why we use it? To create alerts, to troubleshoot, to track SLAs and SLOs. So I'm not sure how many of you are from SRE team, but if you are from SRE team, that you know that your job is relied on SLAs and SLOs and identifying areas of optimizations and reliable release. So yes, these are the regions for it. So now the thing is, okay, so we understand what is monitoring and why do we do that. But when you want to set up a monitoring, then you have to have a preparation plan in place. So what preparation plan you may have it. So you will decide what to monitor first thing, and then how to monitor, and then who will collect the data, and when to monitor. These are the things you have to decide. Okay, what to monitor? You want to monitor Linux server, you want to monitor Windows server, you want to monitor Apache server, you want to monitor Apache applications, Tomcat application, database applications. How to monitor? The process. Who will collect the data? Agent, maybe you need something like an agent. When to monitor? The durations, every 15 seconds, every 1 minute, every day also, every hour also. So these are the plan you need to decide actually. You need to have a plan. Okay. So here at the high level, when we do the monitoring, okay, when we do the monitoring, uh, I told you, right, monitoring is dead now. There's some other word has come, but I'm teaching you monitoring also, so you'll understand that. So let's say if I ask you tomorrow, hey guys, can you go and set up a monitoring using Datadog or any other tools also. See, there are a hell lot of tools available in the market right now. We have Datadog, Neuralink, AppDynamics, Dynatrace, Elastic, Grafana, Nagios, Prometheus. So many solutions are there. So now, if I give you one tool and ask you, hey, go and set up a monitoring, then what you will set up, what you will monitor. So you'll say, okay, let's monitor the process. Let's monitor this memory, threading, CPU, memory, disk, load, network. Let's monitor API call whether it's up and running or not. Response code is you are getting as per the API call means endpoint URL actually. So and stuff like that. Let's monitor our servers also, internals of the systems. So are you comfortable so far? What to monitor and all of you?
Yes.
Yes, Rajesh.
Yeah. So these are the things, these are the technical keywords, but at a high level, you want to monitor availability of the software, whether software is available or not, whether your software is secured or not, runtime environment is secure or not. You want to validate with some data. You want to see the performance of your applications and integration also you want to monitor. So yeah, lots of things we have: applications, services, operating systems, network. You capture the data. See that here. You capture the data for the different locations. Which data? Metric data, and store at some place. Okay. So that is something which we do that. So this is the flow of monitoring: collect information, share information, review meetings, implement changes, review indicators, and also here. This is also flow. So you understand what is monitoring, why do we need it, process, plan, flow, and stuff like that. But why is monitoring so hard actually? The monitoring is hard because of lots of data sources are there. Lots of data sources to collect the data, store the data. Just imagine. Uh, I don't know about your environment like production servers and all, but you know what? In the production server, thousands of servers are running, not one and two. Thousands of servers are running. That's a server. Some of the servers are Linux, some of the servers are Windows. Some of the servers are having installed load balancers. Some of the servers are having web servers. Some of the servers will have app servers. Some of the servers will have a database. I'm just stating the only simple architecture, by the way. It can get complicated a lot when you are in a microservices. So yes, lots of data sources nowadays we have. Okay, and how do you measure that? How do you measure that the your users are satisfied or not satisfied? Look at this one good image here. Two different user request to the different devices. different ISPs. ISPs means Internet Service Provider, reaching to the DNS servers. DNS servers is the place where we have domain name. Then load balancers to the multiple microservices, multiple database. And here one user is getting the response time in 300 milliseconds, and one user is getting a response time in 1.5 seconds. So tell me, what is your job? I think you guys wants to learn monitoring platform. So what is your job then? What job you are going to perform? Tell me. What job you are going to perform? Anyone?
I did not understand your question, Rajesh.
So question is very simple. I log in to Amazon.com and did a lot of things on Amazon.com, and my overall response time was 30 seconds. Okay. My response, sorry, 3 seconds. 3 seconds.
Okay. Okay.
But you accessed Amazon.com and your response time was 1 second. So this is the reality. This is the reality. Now let's go back to Amazon.com and SRE team, those who are taking care of the monitoring as well. So what would be their responsibility? I'm asking their responsibility. You had experience 3 seconds, I had experience 1 second.
Uniformity has to be there, right?
That's something.
Performance.
Job. I'm saying see there a lot of discussion we can make it, but the question I'm asking, SRE team of Amazon, what would be their work
Load
rules and
balancing.
no.
Performance of the server.
No, I'm asking their responsibility, SRE responsibility. See, load balancers are there, no? I talked about it. Again, look at my
Yes.
question. I said, look at the image also. Request is going through the different devices. It can be laptop, different browser, different ISP, different load balancer, different app server, different web server, different database server. And response time for one user is 300 millisecond, and another user is 1.5 second. My question is very simple. What would be the work, roles, and responsibility of SRE engineer? In an indirect way, I'm saying what you are going to do, because you are learning monitoring platform, what you are going to do. Tell me.
So
Optimization.
they might compare and make sure what is the difference for both the users in the time frame.
Correct. So you are going to only one work you are going to do, because if you are learning today, next 5 days, one platform, so your job is to find out why this girl response time is 1.5 seconds. Why? Where is the problem? Is it problem in the devices? ISP, DNS server, load balancer, application server, web server, database server, network, third-party library, payment gateway. Where is the problem? Where is the problem? Where is the problem? Okay? Understood that? All of you?
Yes, right.
Yeah. So, this is the types of monitoring, which we have white box monitoring, and we call it a black box monitoring. Okay, so two types of monitoring we have: white box, black box. Right now, I'm not emphasizing too much. Yeah, so I'm not emphasizing on too much on white box and black box. Okay, because I don't want to complicate too much. But in terms of Datadog right now, these two monitoring is possible. So here at a high level, I want to tell you. Okay, so uh, white box monitoring focuses on the internals of the environment, internals, where you get the fetch the internal information. Black box monitoring fetches the external information. External information means about the CPU, RAM, network, load balances, and all stuff like that. That's external. Internal is inside application, they will get into that. Okay, like a APM is a inside applications, logs inside applications. So they'll get into the inside applications and try to find out this information. So yeah, these are the list of white box monitoring and Prometheus, Jabex, Neuralink, and list of black box monitoring also. So, but nowadays, Datadog is supporting both, by the way, you using APM. That is not the case. So, when you want to implement the monitoring, okay, so these are the phases you have to do. So, first of all, you have to decide what you want to monitor, measurement, then collect that data and store it, then analyze it from the storage, then alert and visualization. So if you look at this here, one thing which you need it for collections, analysis, alerting and visualization, one is storage, right? Correct now? Where all the data can be stored. Agree with me?
Yes.
Yeah. So we'll put the context here, which tool is good for it. But remember this, first you have to decide what you want to monitor. For example, CPU. Then you collect it and store it. Then analyze it whether the CPU is going beyond certain threshold or not. Alerting it and visualizations it. So some of the things I will ignore it in this slides because it's too many things to talk about it. But this slide, I think I feel like a sharing. So guys, nowadays in the world of observability or monitoring, they will say when you want to create a monitoring alerting, then they will say, hey, what do you want to create alert for? Okay, so this standard has been set by the industry, and they say, hey, let's do one thing. Let's set up alert for the four golden signals. Okay, four golden signals. Now, the question you may have in your mind when people will discuss what is a golden signals then? So then golden signals will help you to set up alerting and monitoring for four data. And one is called latency. Second one is traffic. Third one is errors. And fourth is saturations. Okay. So latency, traffic, error, and saturation. Will you remember that? This golden signal concept? All of you? Hello? Yeah. So please keep in your mind, I'm just feeding a new standard keyword in this domain. So that, yes, Deepak, everything will be shared with you guys. Okay, so latency, traffic, errors, and saturations. Okay, so some of the slides I'll just skip it because I don't want to give you too much of jargon so you get lost in start itself. So now you understand about the monitoring world, correct? All of you? Any questions on that monitoring? What is monitoring? Why do we need monitoring? What are the things to do in monitoring? What to monitor and all these phases and sort of it. All of you understood? Any questions? Any doubts? Any questions? Any doubts?
No, Rajesh.
Okay. But I said I'm going to teach you observability. So the question is, what is observability then? So actually, you know what, guys? Monitoring is dead. Yes, monitoring is dead. So if you have come to this session and thinking, I will learn monitoring, then let me tell you, I cannot teach you monitoring because it's dead already. We've been doing monitoring from last 20 years. But today, in this session, I will teach you how to set up observability, not monitoring. So the question you may have in your mind, what is observability? So please understand, it's a very simple difference, but you have to understand that monitoring tells you whether a system is working or not. System is working means CPU is lesser than 50% or more than 50%. RAM is more than 50% or less than 50%, or your application is accessible or not accessible. Okay, so monitorings will tell you something like that, correct? No, all of you.
Yes.
But you know what? When you set up a observability, it will let you ask why is not working. So let's say if your CPU is lesser than 50%, then observability process will let you ask why this is 50%. Okay, why the my CPU is let's say let's put it in this way. Why this my CPU utilization is more than 90% or more than 80%? That's a worrisome, right? That's a not a good sign, right? So why it is taking my CPU of this particular server in my data center, why is taking more than 80%? Why, where is the problem? The problem is with applications. The problem is with some third party applications, networking, request. Where is a log for it? Where is a matrices for it? Where is a all other details for it? So why is not working? That's the difference between observability and monitoring. Monitoring is very flat. Yes or no? Observability let you ask, okay, show me the logs, show me the matrices, show me the application, show me the processes, everything, and then you will get to know, okay, these are the regions. So observability will help you to set up that you know same thing. So observability means assembling all fragment means from logs, multiple types of logs you have. System logs you have, applications logs you have, network logs you have, load balancer logs you have, different all fragments of logs and monitoring tools, the one which you are discussing, and organize them in a such a way so it gives you actionable knowledge which you can use it, so you don't have to spend time on troubleshooting too much. Everything you get spoon feeded. CPU is more than 80% utilized. So for that particular server, you have a logs, you have a matrices, you have a everything in front of you through the observability. So you will take a actionable no, actionable things. So that's kind of things which we have in observability. So yes, monitoring and observability. Once upon a time there was a monitoring, but observability is a superset of monitoring. It provides not only high level overviews of the system health, but also highly granular insight into the implicit failure mode of the system. In addition, an observable system furnishes ample context about inner working, unlocking the ability to uncover deeper systematic issues. Monitoring, on the other hand, is best suited to report the overall health of system and derive alerts. So if you want to know the why it's not working, observability, you should try to focus on observability. So look at this here. This is the pyramid. So monitoring is focusing on alerting and overview of it through the dashboard, whereas observability getting into the debugging, profiling, dependencies analysis, and anticipating the future as well. Okay, so when you set up observability, you have to use all monitoring tools which using that predictable failures. But in observability, you have to also add the automated testings also. Okay, so testing better best effort verification of correctness and put it up together testing plus all the best practices of testing and all the best practices of predictable failure in through the monitoring together, and that is basically best effort simulation of failure modes, and that's called observability. Okay, so monitoring systems should address two questions: what is broken and why. while observability cover a larger scope. Monitoring is mainly used in terms of metrics monitoring. In summary, observability is a property of the system and monitoring is an activity we perform on a system. So look at this here. When you set up a observability hierarchy, so you have to get all the data of the past. Past means the logs, which has happened in the past. You have to get it. Diagnostic. Traces, that means request to the website. It has happened in the past, so you have to diagnose. And you have to get the present data. That means CPU, RAM, and all stuff like that. And you have to get it in the dashboard. So, and prediction, how can you do that? So based on the logging, tracing, and matrices, you can do the prediction using stats and signal. And that is observability hierarchy. So observability, gain understanding actively. Monitoring, consume information passively. Observability, ask a question based on hypothesis, why it's not working, something like that. And monitoring, ask a question based on the dashboard. Observability built to tame dynamic environment with changing complexity, whereas a monitoring built to maintain static environment with a little variation. Now the question is, what is a dynamic environment and what is a static environment? Anyone would like to comment on it? Let me.
Dynamic is which is something keep on changing.
Yeah, example for it.
Cloud.
Cloud, yes, but something else. Something else. See, some of you have worked with a container, Docker, and Kubernetes and sort of it.
I studied it but did not work on it.
Yeah.
Okay, so that's called dynamic environment. Nowadays, you know what? We are not running our applications in virtual machines like VMs and all. So
Right.
we are running in a container.
Containers.
Yes. So containers are dynamic. That means, let's say I created 1000 container today, and after, let's say you want to upgrade it, whole container will replaced. I say replaced. New container will come. And how much time? Within a few seconds. So that's called dynamic environment nowadays. In Kubernetes, we call it a pod. So I would suggest to spend some time with the new technologies also. Spend 2 hours every day for the learning new technology. So your skill set will not become obsolete. Because only you can do that. No one else will. Built to maintain static environment means static environments mean VMs, virtual machines. Most of the time, it will never change. If you have started one VM and you're in production, you will keep running on the same thing and you will keep releasing the new software in the same. So that's a VM, virtual machines, cloud like AWS, Azure, and Google Cloud and all. When you create a virtual machines over there, then it's a static environment. You hardly change it. You don't replace that. So something like that. So yes, so monitoring was built for the static environment, physical servers and all, virtual servers. But observability, which is becoming very popular to maintain the dynamic environment. Why? Because monitoring is not sufficient for the dynamic environment. We have to have a different concept of thinking. Okay, so preferred by developers, which is observability of the system with variability and unknown permutations, whereas the monitoring used by developers of system with little change and known permutations. So yeah, this is at the high level we understand. So observability help you to focus on the metrics, tracing, and log capturing, whereas monitoring only focuses on availability. System is available, okay. Performing well, okay or not. Capacity under planned or more than that, and something like that. So now the question is, how do you do that setting up observability? How do you collect the metrics? How do you collect the traces? How do you collect the logs? So this concept we call it a telemetry. Okay, telemetry. Tele means remote, metry means metro means measure. So collect the matrices from the remote locations. So what matrices you are going to cover? you're going to collect. So you're going to collect the melt. What do you call it? A melt. 4 essentials telemetry data types. So always, I'll put it in a very simple way. If anyone will ask you to set up observability and they will ask you, hey, how can you set up observability? Then simply you say, hey, we have to collect the melt actually. Melt means M for matrices. Matrix means Linux matrix, Windows matrix. Matrix means CPU, RAM, hard disk, network. Matrix of Apache, matrix of Tomcat, matrix of database, matrix of this, matrix of that. That's called M, matrices. Then you need to tell, we need to collect events also. What is events? Anyone would like to tell me? What is events?
Event is a error log.
Events means
Process of the specific metrics.
Yes. Events actually, you know what? Events is also matrix only. But there is a difference between the events and matrix. So matrix will be continuously captured, but events will not be continuously captured. Events means, let me put it in this way. You log in, it's an event. Log out, it's an event. And when you log in and when you log out, I don't know. Okay. You make a payment, it's an event. You delete something, some important things is an event. You add something is an event. Are you getting my points, all of you? Yeah. And logs means, I think I don't have to teach you, you know that there is a logs from the Linux, logs for the Windows system, logs from applications also, log from the network also. And traces means APM. You want to collect, if you do, you want to do the APM, application performance monitoring. So for that you have to collect the trace. How to collect the trace, I'll teach you. So basically, if someone says to you, hey, what is your plan? So you can say, we want to set up observability for our product. So next question, how do you do that? So you have to collect the melt. We have to collect the matrices, events, logs, and traces. Now they'll say, okay, collection is okay, but which tool you are going to do that? Then you can say, hey, we are going to collect the melt using the Datadog or any other tools like New Relic or hell lot of tools which I said. So many tools are there. We have a New Relic, Prometheus, and stuff like that. So we are going to collect. After the collections, you are going to analyze it. And analyzing, you need a very intuitive UI. Analyze means analyze the metrics, analyze the events, analyze the logs, analyze the traces. And after that, you think, oh yeah, these are the key metrics. CPU is a key metrics, RAM is a key metrics, disk is a key metrics. Events means login, logout is a key metrics. Logs, if it is an error with the logs, that's a key logs. And traces, where the response time is more than X number of seconds, that is the key traces. So what you want to do? You want to monitor it, alert it. You want to create alert for it. Are you understanding, all of you? Hello? Yeah. So yes. So 3 pillars of observability: metrics, traces, and logs. And you need to collect, analyze, set alert, and dashboard. 4 things you have to do. Okay. So traces, which we discussed, relationship between events, matrices, measurement of an event, logs, human readable events, and things like that. So observability means logging plus monitoring plus tracing plus visualizations, and so now there are some differentiation factor. You can see that, and here monitoring will tell you which my system available, but observability will tell you how long is my system up. Monitoring will tell you is my system healthy, where observability, what is my system doing. Monitoring will tell you where, when, and where did it occur. And observability let you know why did it occur. Recovery means monitoring will tell you is my system is backed up, And observability tell you what can I do to prevent the issues from reoccurring. So these are the things which we have it. So what is the metrics? I think more or less we understand by now, but I'll put it in this way. Metrics is something, it can be anything. Metric is like collect from the system, applications also, from the infrastructure, like Linux metrics, Windows metrics, Apache metrics, MySQL metrics, Docker metrics, Kubernetes metrics, all this thing. So this is different kind of metrics which we have. Work metrics, resource metrics, events metrics. So here work metrics means you get the throughput information, success rate, error rate, performance. Resource metrics means utilization, saturation, error availability. By the way, resource metrics, have you heard about this? Is the four signals, four golden signals we create, right? Based on that. And events like a code changes, alerts, scaling events, and so. So these are the detailing about the matrices and events, logs, traces, and all this stuff. So more or less, this is the conclusion. So guys, what we are trying to do as part of this session is we are trying to set up a observability. So using observability, we are going to collect, please hear me out. We are going to collect the matrices. We are going to collect the logs. We are going to collect the trace. We are going to collect all this thing, store it at one place, analyze it, create alerts and create a dashboard. And if any issues coming up, let's say there's one issue which is coming up, like in one server, CPU utilization is more than 80%. So the tool should provide me why it is 80%, what processes running, what applications running, what services running, where is the application log, where is the uh, system logs, where is the traces, which request it has come to the server, so that CPU utilization has gone up, tracing the request, everything we should have at one place. And the moment you have everything at one place, that means you have achieved your observability. That means when you go for debugging purpose and you have every sort of data at one window, that means you can say you have achieved the observability and your job is done on that front. So all of you understood that what is observability and how it is different from monitoring.
Hello.
Yes.
Yeah. Last few minutes I joined. How much I've heard from you. It's clear.
Good. Okay. So now this is the only discussions I am having it, and after that we'll get into the things. So look at this here, some of the stuff. You know what? Observability is also hard. Why? Let's understand this. Look at this, how we are evolving. So earlier we were running the software in a physical server, then virtual server, then migrated to cloud. Nowadays we are running in the Kubernetes and Docker and container and stuff like that. So these are the things. Now software architecture also has moved it. So earlier monolithic architecture we had it. Monolithic means MS Office you install in your MS Office you install in your laptop, right? Everything they have it in one package. So that's called monolithic. Then we got internet and migrated to SOA, service oriented architecture. So we had a concept of web server, app server, database server. And now we have a concept of microservices. meant each service got distributed to too many microservices. One function is equal to one microservices. So it's like this. So it's become a architecture change also. So now we have too many microservices. Look at this here. So this is a map of one of the applications which is running on the AWS. And you see that how many microservices, to perform one request, how many microservices they are, transacting. And you need to locate that problem. Where is the problem? Which microservice is the problem? Which services? Which server? And all stuff like that. So too many microservices. Are you understanding, all of you? All of you?
And these microservices communicate through APIs, right?
Yes. Yes. So, what are the solutions which you want to learn? So, these are the solutions right now available in the market for setting up observability. Application availability, is it up? Network availability, server availability, application performance, and application reliability, network performance, network reliability, server performance, server reliability. So we have so many software: Datadog, New Relic, Splunk, Elastic, App Dynamics, Dynatrace, and Grafana. So yes, one of these tools today we are going to learn to set up observability. And this is the end of this session. Any questions, guys?